Okay, Mr. Kwang here. I would like to go through checkpoint 4 with you before your common test. Right, so let's look at question 1. Question 1, you're supposed to write code to count vowels in the word. So remember, a vowel is just letters A, E, I, O, and U. Okay, where your consonants are non-vowel. So you have to use a for loop, write iterative program, count vowel that counts the number of vowels in the word string. So in this case, apple, APPL, you should return 2 because A and E are vowels. Rhythm should return 0 because there's no vowels there. Okay, so to do this, you need to start off by, because it's a count, right, you need to return a number first. So in this case, I will start off with uh, in, with a new variable called count equals to 0. So this is what I'll update. Okay, then after this, for the for loop here, so I just need to go through every letter one by one. So in this case, if I look at apple, I start by going through A. So by going through A, then P, then P, then P, L, then E, right? Okay, so that's how we do this. Let's check. So for letter in string, okay, we can check for this. Okay, so how to check for all vowels, right? Some of you did it this way. Some of you did it this way, equals to A or letter or E, etc, etc. This will not work because sometimes what happens that this will always be true. Okay, if this is not true, but this it will always be true. Alright, so you can't do it this way. So one way to do is to use the check for membership within a string. So what I can do is that if the letter is within this series of letters, so A, E, I, O, U, okay, so what this will do is that basically you will take the letter and then check whether the particular letter you're checking, is it is it one of this A, E, I, O, U. Okay, if it is, then what I do is that we'll add 1 to the count. Okay, if it's not, we can of course do continue, but this is not needed lah. Okay, so you can just skip it. Okay, so just remove this. Okay, then at the end, you just need to return your count. Okay, so your code will run through every letter, check whether it's in A, E, I, O, U. If it is, +1. If not, do nothing. Okay, so just test this. Right, so this should be okay, quite straightforward. Okay, next you have key symbol. So key symbol, right? Write iterative function called label that searches for key symbol, which is %, and inserts the name that's text in place of the key symbol. So for example, in this case, if you run label and health report on %, okay, so each time you see it's a %, you will replace this % with the whatever name that you set as here. Alright, so you should return this. Alright, so basically I need to iterate through this string and then look for the % sign. If the % sign is there, I'm going to replace it with the name they have. If it's not %, you will just keep it. Okay, so the easiest way to do is to create a new string. So what we do is that we will look at the new string. So this new string is at first is an empty string. Then we take the current string that we are using here, right? We'll go through letter by letter. So let's say for example this health here, right? This health here, I'll look at H first. So if H is not a %, I'm going to throw it directly into the new string. Alright, so every letter that's not a %, I will add it as I iterate through it, right? I'm going to add it into the string. Okay, if it's a %, I'm going to replace it. Alright, so I have a new string here. So because I know that my output is supposed to be a string, right? I will create a new string and make sure that the output is a string later. Okay, so again I'll do for Ellie in string. So this will take me through every character in the string. So what I'll do is this. So I will check for if Ellie is equals to %. So this is the symbol I'm trying to find, right? Then what I'll do is that I will new string plus equals name. Okay, so this one, so let me just add some comments here. Check for key symbol. Okay, if key symbol is found, add name in place of key symbol into new string. Okay, well, if you didn't find the key symbol, right, so now it's else. Okay, so this else is basically what I'm checking for is Ellie is anything but the percent, right? So else I just new string plus equals Ellie. So if let's say if I find, let's say for example letter H here, right? H is not the percent, it's not a key symbol, so I just add it straight in, right? So basically, if you run this, let's check, return new string, right? So you can take this and then you can test this again, right? So it should be true, right? But of course you can just maybe just use one of this here. Just use this to double check. This is giving us the correct output. Okay, let's check this. Right? Yep. So it replaces the percent with Jolim. Alright? Yep. So that's it for this one. Okay, next we come to the Lucas number sequence question. First one is the Lucas exit. Okay, for this one here, right, you are given a function called module in Lucas X in module.py. Okay, there's no point opening up this file because the file will look like this. Okay, it's obfuscated, right? So you won't get anything useful from it. Alright, so we can close this and then we can come back to our code here. Alright, so if you want to, right, you can just basically test whether your Lucas code is working or not. Okay, so maybe just start a new cell and then just from CP4 module import Lucas. Alright, then what I can do is I can test Lucas 1 is 2. Is there really Lucas 0? There's Lucas 0, which is 0, and Lucas 2 is equals to 1, and so on and so forth. Alright, so this is working. Okay, so we are looking here for the first number. Using iteration, write the program code for Lucas exit. Then return the first Lucas number which exceeds the value of n. Okay, what I'm looking for now is that, let's say I'm running, I have okay, let's run Lucas 5. Okay, let's pick a bigger number. Okay, so now this is 7, right? What I'm trying to find is if I'm running Lucas exceed 6, right? The first Lucas number that will exceed 6, that's what we want. Okay, I'm not checking for the 6th Lucas number. I'm checking for the first Lucas number that exceeds the value of 6. Okay, so it's not this 5 that matters, is what Lucas 5 is. Alright, so with this in mind, right, let's write this code now. Okay, in this case here, right, because we do not know how many iterations of Lucas that we need to run through, so we cannot use a for loop here. Remember, a for loop is used when we know exactly how many times we're going to do the iteration. So for some of you try to use a while true loop. So you use a while true, then you use a for loop, right? That's fine as well, but I think the method I show you will be a bit more straightforward. Okay, so first thing first, I need to decide when we have a while loop, right? We need to start off with a variable that we're going to iterate through. So in this case, I'm going to call this I equals to, some of you put 0, but remember, right, when we call Lucas I later, right, Lucas 0 does not really exist. Lucas 0 is just 0. So let's start with I equals to 1. Alright, okay, then my condition here is while Lucas I, okay, because it cannot exceed n, right? So this is still less than or equals to n. Alright, while this is true, what should I do? Okay, I will just I plus equals to 1. Okay, so if the current value of Lucas I is smaller than n, I'm going to add 1 to I, and then I will try the next time round again. Okay, that's it. Then after this, I'll just return Lucas I. So this will stop. So this will stop when Lucas I. This will stop when Lucas. Let me type it out first. Lucas I. What am I doing? Lucas I is more than n. Alright, so yep, that's it. So you just need to return Lucas I. Okay, so there are some test cases that which caught you guys out. So there are some mistakes here. Okay, let me just run this and this should be correct. So it should be true for all. Right, but what I'm going to do is I'm going to change. I'm going to show you the careless mistake. One careless mistake was that some of you did not cater for the fact that your Lucas I could be equals to n. So you just let it be while Lucas I is less than n. Remember, I'm looking for the first Lucas number that's larger than n. So equals to n should prompt your code to run one more round as well. So you run this, you realize that hey, now this doesn't work for the third test case 18. Alright. Sorry, this the third from last test case. Okay, another mistake that was common, right, is because you start from 0, okay, you can't really cater for 0. You can't really cater for something that's less than, because there's no limitations based on n. It's just an integer, so you cannot deal with a case where your n is less than 0. Alright, so just make sure that you address these two issues. Okay, yep. Let me check this again. Run this. Yeah, that's fine now. Okay, so this question 3. Okay, next let's look at question 4. Sum the Lucas numbers. Okay, so right now we have to use a while loop here. Right, iterative function called sum of Lucas n to find the sum of the odd value terms, not the odd terms, right? So remember again here we are looking at the Lucas values, not the terms, not the terms itself. Okay, so just to reiterate, so if let's say for example you look at this, Lucas 1 will give you 2, Lucas 1 will give you 2, that this is not an odd value term. Okay, we are looking for this value to be equals to an odd number. So in this case, this is an odd value term, 1 is an odd value term, 3 is, 4 isn't, 7 is, and so on and so forth. Alright, so what we're trying to do here is that we are trying to look for all the sum of all the odd value terms that are less than or equals to n, where n is larger than 2. Okay, so this is an extension from just now the previous question we're doing Lucas exceed. When Lucas exceed, we are looking for the biggest number, for the first number that exceeds, for the first Lucas number that exceeds n, right? So let's look at how I can code this one now. Okay, so same thing first, because we are returning a sum, we will just define a total. A total equals to 0 now, right? So now we can then as we start counting, we also can start to create we also need to create an iteration variable here. So this is count. Let's call this let's just call this I. Okay, I equals to 1. Remember, your first Lucas number starts from 1, right? So now again, while Lucas I is less than or equals to n, this is the same condition as just now. Okay, next I need to check whether it's an odd number. So I'll do if Lucas I, then modulo, which is the percent sign 2 is equals to 1. That's an odd number. I will add this Lucas I number to my total. Total plus equals to Lucas I. Okay, and that's it. Okay, so again this, oh wait, I forgot something. I need to add 1 to my counter. Okay, the thing is that if you, some of you made the mistake of adding this I plus advancing the I inside here. Okay, but if you do it this way, right, this means that your I will only advance if you are currently dealing with an odd number. So if you encounter a Lucas number that's even, right, you will not hit this condition, then your code will be stuck in the loop. So in this case, this needs to come out to the previous come out of the if block. Okay, so once we have this, we can call our return line return total. Okay, so let's just check this, run this, and then run this. Right, so true, so it's okay. So I'm just gonna add some comments here. So this is similar to the previous question. Okay, and this is checking for odd. Okay, odd Lucas I value, not I value. Okay, so I'm checking for Lucas I odd and not the I value to be odd. Okay, if so, add to total. Okay, so count iterable variable, iteration variable should be advanced regardless of previous condition, previous if else block, if block. Okay, alright, so this is question 4. Okay, let's look at the additional question inside your reattempt. So now we're going to do an AP sum. Okay, remember AP, right? We always start with the first number. So A, this is 3. Then each time I add 2, add 2, add 2, add 2. So I need to determine what's the common difference and how many times I add. In this case, the common difference is 2. The first term is A equals to 3 here. So I'm going to write an iterative code AP sum to calculate the sum of all the terms, including the nth term. Okay. So we look at this case here, right? Let me just take this example first, right? So let's use this previous one. I'm going to write this as a markdown cell, right? So what this code is supposed to do, right? Let's say I take AP sum of this question above. So this is 3. Common difference is 2. And then how many times I'm doing? 1, 2, 3, 4, 5. 5 terms, right? It should do this, right? It should take 3 plus 5. Okay, because it is adding 3 plus 2. Okay, plus 3 plus 2 plus 2, so on and so forth, until you hit the last term of plus 11. So you need to add them up. Alright, so this is how it's going to work. Okay, so let's do this. Okay, we can start from A equals to we can start from 0. So what I can do is that we can define one term. Let's call this the current number. Okay, let's call it just current. Okay, current. Right now, before you haven't started your AP, right? So this is current equals to 0, right? Then you define a sum, which is you're going to add everything into it later. So just call it total lah. So total equals to 0. Alright. So now we can do a loop. So in this case, right, if I have 5 terms, right, I need to add it 5 times, right? So I'll do a for loop for I in range n. Okay, so this is basically we'll do it n times because it's 0 to n minus 1. Okay, so this is a case where I'm using I here, but I'm not going to use the I in my loop itself, so you can see how it will happen later. Okay, so let's continue this. Alright, so what I'll do is that first thing first, I will add my total. Okay, so I'm going to advance my current first. So what I can do is that I can a bit stuck here for now. Pause for a while first, let me think. Okay, I'm going to make one change. Because I just want to add the difference, the common difference to my A value, right? So what I do is that I'm going to define my current as A first. Okay, so my current will be equals to A. And then in this case, right, because this will already cover the first term, this is the first term, right? Then what I do is that I will just minus, okay, for range n minus 1. Okay, so this will loop n minus 1 times, right? So that's what we want, because remember right now, right, we already have the first term here already. Okay, so this is since first term already created above. Okay, so I call it lah. Okay, next what I'll do, so once I have this, right, I'm going to take the total, okay, plus equals current. So add the current value to total. So in this case, right, you will first, okay, so this will add the current value into it, right? Once I've done that, I'm going to advance my counter. Okay, I'm going to advance this current by current plus equals to add d to it. Alright, okay, so let's check whether this is correct or not. Then, so this will do it for the correct number of times. Then I'll just return total. Let's check and see. Correct. Okay, false. Okay, what's the problem here? Okay, let's quick check, yeah. Okay, what I'm doing here is that I'm adding the total first, then advancing the current. Okay, so this is not so good because after this, then I will add one, I advance the current, right? So if you think about this, right, if you when you do the last run for this, right, your current is not your total is not updated to include the last run value because you are updating it only right at the end. Alright, so in this case here, what can I do? Maybe let's try to switch these two lines around and see what happens, right? Okay, so let's try to do that. Control X, then let's just put it at the bottom now. Let's run this and then see whether it's correct or not. Still false. Okay. What's the mistake here? Okay. Okay, I'm just gonna do this slowly lah. I mean, I checked what's wrong, but let's just see what happens if I try to print total. Alright. So maybe what I can do is that let's just make our print statements a little bit more descriptive. So what I'll do is that I will print before, okay, let's call this before current iteration. Okay, then I will say okay, let's just call it before this iteration current is curly bracket, total is curly bracket. This will print out the current and total. Okay, so let's look at this and then let's copy this statement here and look at this. Right, so before this iteration, okay, so after this iteration, okay, let's just check this. Okay, let's create a new one. Okay, maybe we do AP sum 235 325. Okay, so let's check. What should I expect from this question here, this answer, right? So let's just do a quick sum of this one over here. 3, 5, 7, 9, 11. 3, 5, 7, 8 plus 7, 15. 15 plus 22. 3 plus, what am I doing? 8 plus 7, 15. 15 plus 9. That will give me 24. 24 plus 11, 35. So this answer should be equal to 35. Okay, so let's just check this, see what we get for this. 32. Right, so this missing something here, right? Oh, my print statement is actually not coming out. Interesting. Okay, let's run this cell first. Okay, let's check print statement. Okay, so let's look at this. You can see that before this iteration, current is 3, total is 0. Okay, then after this iteration, current is 5, total is 5. Alright, so it's adding the next one. Before then is 7 and 12. Then 9 and 21 and so on and so forth. The only problem is that this line here is not adding the total yet. Okay, it's not adding the 3 in yet. So what we can do is we can change up the code a little bit more. I'm just gonna remove quite a bit of stuff here. Let's just okay, let's change my let's just assume that I've already added the first term. So the first term is equals to A, right? So this would just be equals to A. Right? Then I no longer need the current term, so I'm just going to remove the current term. Okay, and then I'm going to clean up my code a little bit more. I'm just going to remove the whole thing. I think it's easier that way. Okay, so now I will do it. Okay, so I've already added A into my total. So now for I in range n minus 1. Okay, so if let's say it's 5 times, right? If my n is 5, now I'll do it for 4 times. Alright, so what I'll do is that I will add, do I still need a total? Do I still need a current? Okay. Yeah, actually I should just keep my current lah. Okay, so current, because I realized that I need to add the current in, because this current is not just adding 2 each time, it's actually adding A plus 2, then A plus 2 plus 2, and so on and so forth. So current was set to be equals to A still. Okay, then maybe I don't need to remove my code just now. Okay, I think let's change back my original code. Alright, so now I go current equals to A. Right, so let's just check for I in range n minus 1, print before this iteration, total is blah blah blah, current plus equals to D, total plus equals to current. Let's check this now, should be fine. Yeah, and now we get it correct. Okay, because now after the first run, total is equals to 3. Okay, so yeah, some live debugging for you to see. Okay, so let's just check our test cases at bottom. I'm gonna comment out the print lines, if not you'll get very messy over here. Just run this and then just run this again. Yep, so it's true. Okay, yep, so that's all. Hopefully you have time to review this before your CT1. Okay, otherwise you should seek help before the CT1 itself. Okay, thank you, bye bye.